There is an object that physicists have known about for over 100 years. It is written into the deepest equations of physics. It is mathematically unavoidable. It should exist. And yet, no telescope has ever seen one, not once. Some scientists believe that is because we are looking for the wrong thing. Others believe something far stranger, that we have been staring at them our entire lives and simply did not recognize what we were seeing. What you are about to hear is not science fiction. It is not a fringe theory from the internet. It is a hypothesis developed by some of the most respected physicists alive, published in peer-reviewed journals, and it will change the way you think about everything. The Big Bang, dark matter, black holes, where the universe came from, all of it. This is the story of the white hole, and it starts with a question nobody has been able to answer. You already know what a black hole is, or you think you do. It is a region of space where gravity has become so extreme, so absolute, that nothing can escape. Not light, not radiation, not information. You cross the event horizon, and that is it. The universe outside simply stops existing for you. You fall inward, faster, faster, toward a singularity, a point where all our equations break down and physics itself gives up trying to describe what happens next. Black holes are real. We have photographed them. We have detected the gravitational waves from their collisions. We know they exist scattered across every galaxy in the observable universe, including our own. But here is the thing that most people never think about. The mathematics that predicted black holes, the equations Einstein wrote in 1915. Those equations have two solutions, not one, two. And the second solution describes something that should be just as real, just as inevitable. An object that is the exact opposite of a black hole in every possible way. Einstein's general theory of relativity is symmetric in time. That sounds technical, but what it means is simple and deeply strange. If you take the equations and run time backward, you get a mirror image. A black hole run in reverse. And a black hole run in reverse is an object from which nothing can ever enter. An object that only pushes matter and light outward. An object that erupts, continuously, unstoppably, forever expelling everything away from itself. You cannot fall into it. You cannot approach it. Anything that gets near is simply thrown back out. Physicists call this a white hole, and the equations do not treat it as a curiosity or a mathematical error. The equations treat it as a real physical object that has every right to exist in our universe. The problem is, we have never found one. And that silence is one of the strangest mysteries in all of physics. The story actually begins in 1916, 1 year after Einstein published his theory of general relativity. A physicist named Carl Schwarzschild sits down and solves Einstein's equations for the simplest possible case, a single point of mass in empty space. He expects a clean, simple answer. What he gets instead shocks him. His solution has two regions, two separate pieces of space-time. One region pulls everything inward and never lets it out. The other pushes everything outward and never lets anything in. A black hole and a white hole, connected, according to the mathematics, by a tunnel through space-time. A bridge between two universes. We call it a wormhole today. Einstein himself later worked on this with Nathan Rosen, the Einstein-Rosen bridge. At one end, darkness that swallows everything. At the other end, something that erupts, something that pours matter and energy outward into space, something that looks, if you think about it carefully, like a creation event. Now stop. Think about this carefully. A white hole is an object that erupts from a single point. It pushes all of its matter and energy outward in every direction. Nothing can enter it. It simply explodes into existence from something impossibly small and impossibly dense. 13.8 billion years ago, from an infinitely small point, all the matter, all the energy, all of space and all of time in our universe suddenly burst outward in every direction. We call that the Big Bang. Carlo Rovelli, one of the most brilliant theoretical physicists of our generation, has asked the question publicly in published papers. What if they are the same thing? What if the Big Bang was not a unique event with no explanation? What if the Big Bang was a white hole, born from a black hole in another universe, on the other side of a tunnel through space-time? The idea sounds impossible, but the mathematics, the exact same mathematics that correctly predicted black holes, gravitational waves, and the expansion of the universe, does not rule it out. It invites it. But if black holes become white holes, how does that actually work? This is where Rovelli's theory of loop quantum gravity comes in, and it changes everything. In standard physics, in Einstein's equations, a black hole collapses forever. The core shrinks without limit toward a singularity. Infinite density, infinite curvature. The equations break. But loop quantum gravity says that cannot happen, because space itself is not continuous. At the smallest possible scale, the Planck scale, space is made of discrete chunks, tiny quantum grains, and you cannot compress those grains beyond a certain point, so the collapse stops. And then, like a spring that has been compressed as far as it can go, it bounces. The black hole explodes from the inside. It becomes a white hole. All the matter that fell in, over billions of years, gets ejected back outward. From our perspective outside the black hole, this happens almost instantaneously. But from inside the object, where time runs at a completely different rate, this process could take trillions upon trillions of years. The black hole simply waits. And then one day, it turns inside out. Every single day, our telescopes pick up explosions across the universe that we cannot explain. Fast radio bursts, millisecond flashes that release more energy than our sun will produce in 10,000 years. They come from random directions. They do not repeat. They leave nothing behind. We do not know what they are. And then there are gamma-ray bursts, the most powerful explosions in the universe since the Big Bang itself. Beams of energy so intense they could sterilize entire star systems from across a galaxy. We understand some of them: colliding neutron stars, dying massive stars. But not all of them. Some gamma-ray bursts do not fit any known model. And a handful of physicists have started asking a question that sounds almost too strange to take seriously. What if some of these explosions, just some of them, are white holes? Black holes that finally bounced. Ancient objects that fell silent millions or billions of years ago and are now erupting back into existence. We have never been able to rule it out. Here is something that should disturb you. 27% of the universe is made of something we cannot see, cannot touch, and cannot detect with any instrument ever built. We call it dark matter. We know it exists only because of what it does to the things around it. Galaxies spin too fast at their edges. Something invisible is holding them together. Light bends around regions of empty space. Something massive is warping the path. Whatever dark matter is, it outweighs all the stars, all the planets, all the gas and dust in the visible universe, combined. And we have no idea what it is. One of the leading hypotheses right now is that dark matter could be primordial black holes. Tiny black holes formed in the first fractions of a second after the Big Bang, before any stars or galaxies existed. Microscopic, invisible, scattered through space in enormous numbers. And if that hypothesis is correct, then by Rovelli's logic, each of those black holes carries a clock inside it, ticking down toward a bounce, toward the moment it becomes a white hole and begins to radiate matter back outward, into our universe. Right now. In 1974, Stephen Hawking proved something that stunned the physics world. Black holes are not eternal. They evaporate. Quantum mechanics forces pairs of particles to appear spontaneously near the event horizon. One falls in, one escapes, and slowly, over unimaginable timescales, the black hole loses mass. It shrinks. Eventually, in theory, it disappears entirely. This is called Hawking radiation. But Hawking's discovery created a crisis that physicists are still arguing about today. It is called the black hole information paradox. Quantum mechanics has one absolute rule: information cannot be destroyed. The precise state of every particle that ever existed must be preserved somewhere in the universe, even if scrambled beyond recognition. But when a black hole evaporates, it seems to take all that information with it into nothing. It violates the deepest law of quantum mechanics. Where does the information go? A white hole solves this perfectly. The information does not disappear. It goes through. It comes out the other side, in another place, in another time, in another universe perhaps. The information is not destroyed. It is redirected. The James Webb Space Telescope has been staring into the earliest moments of the universe, and what it is finding is deeply unsettling to our standard models of cosmology. Galaxies that should not exist yet already do. Massive, structured, chemically complex. Hundreds of millions of years after the Big Bang, when our models say the universe should still be a relatively formless fog of gas, Webb is finding galaxies that look billions of years old. Astronomers are calling them impossible galaxies. They are not impossible, but they require an explanation. One explanation, quiet but gaining traction, is that the Big Bang was not a blank start. If the Big Bang was a white hole, then the matter it ejected was not pristine, structureless hydrogen and helium. It was matter that had already existed, matter that had already fallen into a black hole in some previous universe, matter that already carried structure, complexity, seeds of organization. And if that is true, then those early galaxies were not built from scratch. They were built from the ruins of something that came before us. Follow this logic to its conclusion, and you arrive somewhere extraordinary. If black holes become white holes, and white holes are creation events, then every black hole in our universe is the seed of a new universe, a daughter universe, born through a white hole on the other side. Our own universe was born the same way, from a black hole, in a parent universe. We will never see that parent universe. We can never communicate with the daughter universes being born inside our own black holes right now. The universes are causally disconnected, sealed off from each other by the event horizons that separate them. But they exist, and the universe is not a single isolated event that appeared from nothing. It is part of a chain, a lineage, a cosmic family tree stretching back through time in a direction we have no words for. This is not philosophy. This is not poetry. This is a testable scientific hypothesis, developed by Rovelli and his colleagues, with mathematical predictions that future observations may be able to confirm or rule out. So why have we never directly observed a white hole? The answer may simply be timing. If a black hole must compress to Planck-scale dimensions before it bounces, and if time runs differently inside the black hole, then the bounce could take an almost incomprehensible amount of time from the outside perspective. The black holes formed in the early universe, the primordial black holes, are the most likely candidates. Small enough to have compressed fully, old enough to be approaching their bounce. Some calculations suggest the timescale is around the current age of the universe, which means, if the theory is correct, we may be living at exactly the right moment in cosmic history. The first white holes may be erupting right now, somewhere out there. What would they look like? Nobody knows for certain, but the next generation of telescopes, more sensitive, more precise, covering wavelengths we have barely explored, may be about to show us something that rewrites everything. We have mapped the visible universe out to 46 billion light-years in every direction. We have detected gravitational waves from collisions that happened before our solar system existed. We have photographed the shadow of a black hole. We have landed machines on other worlds. And yet, the most fundamental question remains completely open. Where did all of this come from? The standard answer is the Big Bang. But the Big Bang is not an explanation. It is a description. It tells us what happened. It does not tell us why, or what came before, or where the energy came from. A white hole does not answer all of those questions, but it answers one of them. It says, the universe did not come from nothing. It came from somewhere. From something that existed before, from a black hole in a universe we will never see. Einstein's equations have never failed us. They predicted black holes before we believed they were real. They predicted gravitational waves a century before we detected them. They predicted the expansion of the universe before anyone thought to look for it. And those same equations, written in 1915 by a man who could not have imagined the Hubble Space Telescope, tell us that white holes must exist. We have not found one yet, but somewhere in the darkness between the galaxies, something is waiting to be born. Something is about to turn inside out. Something is about to become a Big Bang for someone else, in a universe that does not exist yet. And the clock, inside some ancient, silent black hole, is almost out of time.